Today's topic of discussion is one-step equations. Equations are different than just simplifying algebraic expressions is because this time we have an equal sign thrown into our problems. And our goal is to get the variable that is in the problems to be the only thing on its side of the equal sign. So if we were playing a game, we could say that the object of our game is to get the variable by itself. And in order to do so, we have to first be aware of opposite math functions. Addition and subtraction are opposite math functions. Multiplication and division also go back and forth as opposite math functions. And we're going to be using these facts when we solve our equations. Let's look at example 1. Example 1 has x minus 3 equals negative 8. I'm trying to get x to be the only thing that's on the left side of the equation. So I need to move this 3, and I want to move it across the equal sign. So I'm going to start by drawing a line down my equal sign so that I can see exactly what side I'm trying to move it to. Since we are subtracting 3 in this problem, I am wanting to add it to both sides to do the opposite. What's going to happen when I combine these together is that I have my x drop down. Negative 3 plus 3 will turn into 0. I will drop down my equal sign. And I simplify negative 8 plus 3, which is negative 5. I only want to add my number 3 on each side one time. And so by drawing this line here, sometimes that helps us to distinguish what side we're on. To further simplify, I say that x plus 0 is x, drop down the equal sign, and I drop down my negative 5 since there's nothing else on that side I can do with it. X is now by itself, which means that I'm allowed to stop, and that means that x minus 5 is my answer. If you are more comfortable leaving this line out, you can do so. That is not required to solve the problem. Let's look at example 2. This time in example 2, I have the equation x plus 15 equals 3. This time I see addition. So I'm going to do the opposite, which is subtraction. And I'll try this problem without our line like we had in example 1. So we will be subtracting 15 from the left side of the equation and moving over to the 3 on the right side and subtracting 15 there as well. Now, most of us are probably more familiar with the term canceling or crossing out. And we've seen this in middle school before. So when we're looking at this, I have 15 minus 15. The reason that is able to cross out or cancel is because that turns into 0, and we can see that from example 1 up here. Anytime we add or subtract numbers, we always want them to turn to 0, and since 15 minus 15 is 0, that is why I'm allowed to cross it out. I'll drop down my x, drop down my equal sign, and 3 minus 15 simplifies to negative 12. My x is all alone. There's nothing else I can do on the right side with the negative 12, so this will be my answer. For example 3, our first thought is to say, oh, we've got addition, so let's do subtraction. But let's look to see what happens if I do subtraction. If I subtract a 10 on both sides, when I get ready to cancel, a negative 10 minus 10 is not going to give me 0. And I need this number to be able to disappear. Our ultimate goal is to be able to cross those out. But we can't do that if their signs are the same. So instead of subtracting in this problem, we're going to add, because negative 10 plus 10 equals 0. And here's why that works. We can rewrite the original equation to be x minus 10 equals 14. So this is just switching our x and our 10 here, and we'll get x minus 10 equals 14. If we looked at this equation, it's very obvious to see that we would add 10 on both sides in this situation. Over here in the backwards form of it, we still have to add 10 to both sides, but it's not quite as obvious. But the way to check it is just to make sure that when you cross out a number when adding and subtracting, you want to make sure that they are adding and subtracting to equal 0. So now that we've done that, we have our x is equal to 14 plus 10 is 24. And since x is by itself, x equals 24 will be my answer. For example 4, this time instead of adding or subtracting, we see a product. 3x equals negative 39. If you'll remember from the beginning of our notes, the opposite of multiply is divide. So I'm going to divide the left side by 3. What this is going to do is simplify down to 3 divided by 3. That's 1x. So now I have x all alone here because there's an invisible 1 coefficient right in front of it. But if I do that to the left side of my equation, I'm also going to have to do it to the right side because equations are like scales and you need to make sure that they are balanced. So whatever's done on the left has to be done on the right side. And now we simplify negative 39 divided by 3. That's negative 13. Since x is all alone, I can stop and circle my answer. In example 5, we have a division problem this time. This time I see that I have negative x divided by 4 equals negative 12. What we'll have to do is move this 4 by doing the opposite, and the opposite of divide is multiply. But notice that it also has a negative in the front right here. I need x to always be positive. So what we're going to do is when we multiply by 4, we're also going to multiply by the negative because a negative times a negative makes a positive. So if I do negative 4 times negative 1 over 4, my 4's will cancel and the negatives will also turn positive. So that will give me a positive 1x on the left. But once again, if I do it on the left, I have to do it on the right. So I'm going to multiply the right side by negative 4. Negative 12 times negative 4 is positive 48. Since x is by itself, we've got our answer. Moving on. Example 6. This is a little bit different and can be a little bit trickier because now we're involving a fraction as a coefficient. But it's nothing to worry about. We can take this and solve it one of two ways. Here's the first way. The first way is to treat this as two separate problems. So I have a division here, but it's also being multiplied. What I'm going to do is get rid of this denominator because most of us hate fractions, right? So let's get rid of the denominator by multiplying, since the 4 is being divided here. So I'm going to multiply both sides by 4. When I do that, my 4's cross out on the left side, and I have 3x is equal to 36. Then we divide both sides by 3 since 3x is a product. My 3's will turn into a 1, so I'll cross those out. And 36 divided by 3 is 12. I've got x by itself, I've got my answer. That's the first way to solve it. A second way that some of you may like better, and let's see, I'll rewrite this right here. We have multiplication between the fraction 3/4 and x. The opposite of multiplication is division. Now when we divide fractions, we always do the keep, change, flip method. You keep the first the same, change division to multiplication, and then flip the fraction. So what I'm going to do is keep my first coefficient the same, and I'm going to multiply. Then we have to flip it upside down. And this looks similar to the way that we've done it with multiplying regular fractions like we've done in elementary school, we can do the cross-cancel method, and this will turn into a 1x. But if we do it on the left, we have to do it on the right. So I multiply it on the right side, and I multiply the same exact thing, 4/3. So I'm going to have 9 times 4/3, and what I can do is put the 9 over the 1 and then do a cross-cancel method. 9 divided by 3 is 3. 3 times 4 is 12. So I can get the same exact thing. And this will conclude our one-step equation notes.